Okay, so I think everything's recording now. So yesterday we did confidence intervals when the standard deviation was known, but when we think about it, that doesn't happen. If we know the standard deviation, then we don't need to find all these means and then find the mean of all these means. So we don't have to do that. So for today, what we're going to do in 7.2 is the standard or the confidence intervals when the standard deviation is unknown. Maybe, where's my mouse? I don't know where is it on here? Okay. Is it gonna go? Okay. So the value of sigma when it's not known must be estimated using S. So we're gonna call it S for our standard deviation of the sample. So sigma is Greek S, so now we're gonna use Roman normal S. Okay. When S is used, especially when the sample size is small, so small we're thinking less than 30, critical values greater than the values for Z alpha of over 2. So kind of remember where that came from. Remember the Z alpha over 2 was when I have my random, any old Z-score type thing, or not Z-score, any normal curve. Remember that Z alpha over 2 was because I split the tails to this half and this half. So then I would have 90 or 95 or whatever random percent I pick to have in the middle. Okay, so they're used in confidence intervals in order to keep the interval at a given level, so such as that 95%. So remember, that's how we pick those Z's. So we're going to use S. It says this in here. It says taken from the student t-distribution. I've never, ever, ever heard it called the student t-distribution. I've heard like the t-distribution. So where we're going to find that t-distribution chart is in the back of your book. There's a section called Appendix C, and it's all just tables. So it is on page 786. I don't know, can you see that there? It's kind of, not really. Okay, so it kind of is just a bunch of gibberish right now. So we'll talk about how to use, I just let my finger out of the book. So now I have to go back to section. It's just that one table. Let me get to the beginning of it. Okay, so we're going to use that. We're going to have to flip back and forth eventually, maybe not right away. That is what we're going to use for the t-distribution. There's my marker thingy. Okay. It's pretty similar to the standard normal distribution. You want me to go back?
Yeah, we'll go.
Okay. Yep. Which one are you at? Yeah. Oh, okay. I don't know who calls it a student one. So it's still bell-shaped. Everything we're going to do is bell-shaped still. It's symmetric about the mean still. The one in your book and that chart in the back, it kind of has that same property as your regular normal curve, that the normal or the mean is at 0. So mean, median, and mode are all equal to 0 and are in the center of distribution. Okay, that's why we normalize things, is to get those scores where we can see them. The curve never touches the x-axis, so it just kind of goes on forever on both sides. So same thing that the other one did. Is that my last thingy? Okay, so that's the last thing on that one. Okay, so symmetric just means both sides have 50% of the data on them. Okay, it's different because the variance is greater than 1. Remember that our variance used to just be equal to 1 for that standard normal thing. The weird thing is, and even looking at that chart, you see something of, I think it says DF in the left-hand side of that column. And what that represents is the degrees of freedom, which is related to the sample size. So it actually is going to come directly from the sample size. Our degree of freedom will be 1 less than whatever our sample size is. So we'll talk about that. Yeah, it is kind of a weird idea. as the sample size increases, the t-distribution approaches the standard normal distribution. Okay, so I'm just kind of reading those things. Whoops, I'll go back. Maybe if I can find my thingy. Okay. So we'll use df. So anytime that you're given my n, so n is your sample size still, n still represents the same thing, we'll just write like df equals 1 less than that, whatever. We don't really have to write the -1 piece because we can subtract 1 pretty easily. Okay. Don't always use that for your degree of freedom. For this chapter, yes. Later on, not necessarily. Okay, so we might have different types of degrees of freedom. Whoops. Do you have that now? Okay, and then we're going to use a new formula. Okay, so remember this is for when sigma is not known. So basically, if in the question somewhere they tell you, they don't say anything about what the standard deviation is, then we're going to use this formula. Okay, it's very, very similar to what the other one was. Okay, so before we just had x bar minus, this is getting to be kind of terrible marker. Okay, so yesterday what we had was x bar minus z alpha over 2. I'm trying not to get in the way of it. Then we had sigma over the square root of n. Okay, that's what we had yesterday. So that is the only difference. So we had basically a plus minus thing of that. Okay, so the difference that we're going to do is our n is still in the same place. Standard deviation is the formula we're going to use to find that guy.
Formula, that's the word I was wanting last night.
Formula.
Don't know I can find that word.
Okay, so we're going to have to find our t-score. So before we found the z-scores for things like we did yesterday and the last few chapters, now we're going to have to find t-scores. Okay, and they're going to tell us those. So anytime we need to know df, so remember df is something that we just have to find on that chart. It's not in the formula, but it's used to get something. What? I didn't hear you. DF? Okay, so let's do, did you have it written down?
Degrees of freedom are n-1.
Mm-hmm. Okay, so what page is that? I'll just sample or example 7.5. So what it says is find the t, you can just say the t value. We don't have to say the whole thingy. The t value for the 95% confidence interval when the sample size is 22. So kind of open up your little chart deal. Let me put I need a bookmark or something. Okay, so I'm looking in my little table thing. I'm over here. So if my sample size is 22, I have to say, okay, my degree of freedom then is 21. What? Did you just yawn? I don't know. Oh. Just was like, and I'm like, I don't know what you're doing. Okay, so I'm looking at 21 over here. So then there's also, they say 95%. So let me see here. I can't look at it very good. So over at 21, 95, I have 2.080. Okay. So I need to keep losing everything. Okay, so degrees of freedom, 21. We go in there and we say, oh, look, 21. See, we already found all that stuff, so we know how to do it. There's a picture in case you didn't get it. Okay, so the next example. That is for finding the t-scores. Yes, that's all you'd have to do. Okay, so actually now to use it. So 10 randomly selected people were asked how long they slept at night. The mean time was 7.1 hours. So this is my x bar. You can write mu still, I don't care. The standard deviation was 0.78, so this is my sample standard deviation. Find the 95% confidence interval. So we're going to use that. Of the mean, assume the variable is normally distributed. So I had, it said 10 people. So my degrees of freedom will be equal to 9 people. So I'm going to go on my chart. I'm going to go find my 9. So on the left side, I find my 9. Then I need to find my score. It says 95%. So 2.262. They... Okay, hopefully, let me see if my formula will just pop up nicely. Okay, we found that. Okay, so now we're plugging it into this formula. So my x bar was 7.1. So I have 7.1 minus my t score was 2.62. I said that wrong. 2.262. Okay, my standard deviation that they gave me was 0.78 over the square root of 10 because I had 10 people. So basically, if you just add and subtract that, we will get our two areas of that boundary. Interval. Interval is the word I was looking for. Okay, so I'm waiting, but I'm waiting on the wrong thingy. Okay, we plug all those things in. And then we're going to do the math for us. So what you need to do is just type in this big gross thing in the calculator. And then don't do the 7.1 till like the last thing. And that will keep everything kind of in the best order possible. Where's my thingy-majig? Okay, so when you add and subtract those, you get 6.5 and 7.7. Okay, so then kind of how you put it back into words. One can be 95% confident that the population mean is between 6.5 and 7.7 hours. Okay, so that's how you need to rephrase the answer. Don't just say 6.577. Okay, that doesn't, everybody looks at that and is like, no idea what that meant. Okay, so the next one, let me get it to there on there, is the data represent a sample of numbers of home fires started by candles for the past several years. Find the 99% confidence interval for the mean number of home fires started by candles each year. So they actually give you the data, so you have to go through the work of actually finding the mean. Okay, we will do that real fast, but then hopefully you will not have to spend much time doing it. So to find the mean, let's going to go over how to do it in your calculator as well. So to find my mean, I want to, let's pretend like this was way more than just these numbers. So if I had like 30 sets of data or something. So I go push my stat button, and then I put my edit. I want to clear my L1, so I go up to L1, come back down, cleared. Okay, I'm going to type in my 5460, 5900, 6090, 6310, 7160, 8440, 9930. Okay, quit out of that, so second mode. Okay, stat, calc. I want my 1 var statistics, 1 variable is all I typed in there. Okay, my list L1, calculate that guy. It tells me my X bar is equal to 7041.43. And then it also, what is the other piece of information I need to know for this formula? So I have to find my standard deviation, which is, so X bar at least looks like X bar. The standard deviation looks like SX is what it looks like in the calculator. And that is 1610.27. Okay, so now when you go to find that, so you have to do a little bit in the calculator.
X, right?
Yes.
Okay.
Yeah, but I'm just showing you how it looks in the calculator.
You can do the whole, what do you enter that in to
The L1. So you do your stat, L, list, or edit, and it brings you there. So make the calculator do that work for you. Remember that was that one really gross chapter of finding the standard deviation and variance. We don't want to do it all by hand because it's gross. Okay? Totally can. We're just, if you ask me how to do it, I'm going to tell you to type it in your calculator because we're not going to type that much stuff anymore. So we use our little formulas. Is my formula going to pop up? No, not yet. So I have my t-table now. it says how many people. Okay, so you have to count. I have 1, 2, 3, 4, 5, 6, 7 things of data. So my degrees of freedom then would equal 6. So I'm looking on that 6 on that left-hand column. 6, and it says it wants a 99%. So I go all the way to the right-hand column, and I should get 3707. So for my T alpha over 2 is 3.707. Okay, and then I'm going to plug it all into my formula. So my x bar, remember I had basically x bar, not wrong bar, please. Basically just plus minus my t-score times s over square root of n. Okay, so the upper one will be the higher limit, lower one will be the lower limit. X bar 7041.43 plus minus my t-score of 3707. My S, so 1610.27 over the square root of 7, because I had 7 pieces of data. Okay, so when you're typing that stuff in the calculator, make sure you're just doing the grossest looking piece first, so that guy. So I have 3.707 in parentheses 1610.27 divided by square root 7. Whoops. Make sure you get parentheses in right places. So I have 7041.43 plus minus 2256.17. Okay, so now I'll do the 7041 plus that number. That will be my upper limit. And I get, so I need to write it back as mu, should be 9297.60. I'm going to do the same thing with a minus. 4785.26. Okay, so to put it back in words, we are 99% confident that the mean number of home fires started by candles each year will be between 8,500 and 9,200. Okay, so you need to come back and say that kind of in a sentence to make it make sense. So remember kind of from yesterday, this is a very large range of things. Okay, remember that very large range happens when I get very confident. I am 100% sure that there's more than 1 million stars in the sky. Okay, yeah, there's probably, like, we can't count, there's infinite numbers, so so I'm very sure, so there's very big gap. That was a really bad example. So I think that was the last one even. So it kind of went through it all for us, but over a period of 7 years is what it said too, because I guess that was for each year. Okay.